Welcome everybody. So let's get started with this year's Projekt Fórum. My name is Máté Cserép and I will be the moderator for this event. And first I would like to summarize that what is the goal of this Projekt Fórum, then go through some technical details that how this event will go, and then we will continue with the presentations. So the goal of this Projekt Fórum is to give you, the students, a broad overview about the research development projects ongoing at the faculty, or at least some of these research development projects which are ongoing at the faculty, which you can join and participate in them. And by doing that, so by participating in this project, you can not only gain experience, but as an outcome, you can usually also write your bachelor or your master thesis to conclude your studies. Maybe even write a thesis for the Scientific Students Association Conference in Hungarian TDK conference. So it's also a good opportunity to write a TDK thesis in your studies. And in some cases, for some projects, it's also possible to do your mandatory internship program if you would like to do that. So you can not only do that outside the university, but in some cases, it's also possible to do this internship program by participating in some of these projects. If you are a master's student, you can also get credits for participating in most of these projects. So in most cases, you can apply for a special laboratory course during as part of your degree program, and then you can also get credits by participating in this project, but this varies by project, so you have to discuss that with the project owners for each project. So that would be the goal of this Projekt Fórum, to give you an overview, and let's go through the technical details. So altogether we will have 10 presentations today. The first presentation will be a video presentation, but the further presentations will be a real IRL presentation here. And I would like to ask each presenter to make a do your presentation in approximately 5 minutes. So please try to keep that time frame. I will be sitting on the side and I will raise my hand if you have 1 minute left. I won't stop you, but please try to be in 5 minutes. After each presentation, we will have a short questions and answers session, and I will ask you to ask your questions online. So there is this website slido.com, and you have to enter an event code. It's PF, like Projekt Fórum 2023. I think this event code is maybe also written somewhere here. You can see that. And you can ask your questions online, and I will read your questions after each presentation. I would also like to ask you to start your question with the serial of the presentation. So, for example, number 2 with for the second presentation. So in case some of the questions arrive a bit late, the questions won't get mixed up that which presentation they belong to. After the event, so after all the presentations, we will also have a networking and discussion session. The organizers prepared with some catering over there. So I would also like to ask the presenters that if you have time, please stay here. So after all the presentations, the students can contact you and discuss you if they are interested in your projects. So please stay if you have time. And then for the students, you will have the opportunity to do that. Yes, that's an important thing. I think we have went through all the important technical details. So let's get started. As I have promised, the first presentation will be an online presentation. So I will start that one. This presentation will be about open source AI and data science framework development from Franz Király. And you still have the opportunity to ask questions because we have Imre Lendak here with us. And I was promised that you can answer the questions if somebody has some. So still it's a video presentation, but if you have questions, feel free to ask questions already.
Hello and welcome. And I'm really sorry I couldn't make it today in person. I'm going to present a series of projects on the topic of Python open source AI framework development. I hope this video works as intended. So what is this about? Most artificial intelligence, practical data science, and deployment actually runs on open source business logic. Examples that you will probably know: scikit-learn, PyTorch, TensorFlow, Hugging Face. And of course, it's not just a key skill to use these software toolboxes, but it's also extremely important in today's ever-evolving landscape, how to build and extend such software. The best and only way to learn that is actually doing that, actually using the software, extending and building it. and the projects that I'm presenting are about learning how to do that from experts in mentored projects. At the Institute for Industry Academy Innovation, we're closely integrated with the open source ecosystem. We use open source every day. We have software engineering design expertise in deployment, and some developers who are closely involved or have founded open source packages like myself. SK-Time, if you have seen it, the scikit-learn-like library, scikit-learn-like compatible for time series. It's a blueprint marketplace, hundreds of contributors, 1 million downloads per month. So it's a household name in the space for time series modeling. And of course, we're happy to mentor you using that or any other popular project that you might choose. SK-Time supports multiple time series tasks, starting from forecasting, over classification, regression, transformations, and more. It's ever evolving. Some of these modules are actually maturing and have nice opportunities for getting involved with, or there's opportunities for creating your own specific modules as well. Just to show how it looks like, very similar to scikit-learn if you've seen it before. Simple vignettes, data loading, estimator definition, estimator fitting, using the estimator to make a prediction, in this case a forecast. So of course this will look differently for different types of estimators. It's mostly the same principle that you know from the popular Python toolbox, is pip install and then plug and play. The unified interface means that all that changes is the estimated definition, and that can become arbitrarily complicated. So the framework type toolboxes that we have looked at previously on the previous slide, the power stems from the ability to combine components, estimators to pipelines, tune them, build AutoML composites to improve, for instance, the quality of your forecast. Here's an example of composition, again from SK-Time. If you know scikit-learn, it's also very similar. So have transformation pipelines for forecasters and all the other estimators in the package. Research and project opportunities, of course, software engineering and design. If you're a Pythonista, then you can think about the architectural framework level or backend deployment, so deployment, cloud and database layer. There's development roadmap items as well. So some important ones: pipelines, time series annotation, anomaly detection, change point detection, integration of deep learning and distributed backends, for instance, PyTorch and Polars. Benchmarking is also important, a highly requested feature on which multiple developers are working. We have multiple frameworks to consolidate there. For performance testing, that means predictive performance as well as computational performance. It touches the trustworthy AI topic, for instance, the M4 and M5 competitions, if you've heard of them. We would really like to set up some empirical studies as well to compare different forecasters or different estimator types. So that's also a really nice research task, including methodology development there. How to get started? Well, you can get started anytime online with a good first issue contribution. Each open source project, including SK-Time, has good first issues for new contributors. We're happy to mentor you on other open source projects of your choice as well. If you need academic accreditation, you should keep in mind this might require prior registration and might have requirements from your course manual or research component. So if you want to accredit this for an academic project, you need to contact us prior to starting with the accredited part. Of course, with the good first issue, you can always get started first. If you want further advice or mentoring, message me directly. If you have a longer project interest in that email, please include a short background. And if an accreditation is needed, then please let us know for what. Looking forward to see you on one of these projects. Thank you very much.
I do not see any questions. In that case, let's continue with the second presentation. So please, oh, okay, it was just a bit late, but you can still answer that question. So we have a question that what was the prior experience? No, sorry, I need to rephrase this. that what prior experience is highly recommended for these projects for the students to have. I also give you this microphone, yeah.
Thanks for the question. Mostly what we are looking for is Python and an interest for data science, and yeah, and that at least some level of previous data science experience is well, desired but not absolutely necessary. You know, a certain level of Python skills is usually necessary.
Okay, so let's say if some student is in a bachelor program, at what level they are expected that they can join this project and they can benefit from this project?
As I will say in my next presentation, we worked with second year bachelor students and third year, absolutely. It depends. So some students already have experience at that age, at that stage of their studies, but it depends. So yeah. We work with second year students as well. Okay, thank you. Hopefully this will work, and I hope you can hear me. My name is Imre Lendak. I am an associate professor at the Department of Data Science and Engineering. Usually we were joking that I was the engineering part of the department because I'm originally trained as an engineer. So that's my bias if you see any in the presentation. The project I am here to present is the CDNO project, the Content Delivery Network Optimization research project we are undertaking together with Deutsche Telekom and T Labs. It started because the partners were motivated to incorporate data science and optimization and some prediction tasks in their new TV service, which is offered to, well, millions of customers in Germany. And the idea was, their idea was and is that they will develop an open source based platform, so they will not pay to, let's say, Netflix or somebody similar to actually give them a system, but they will build their own open source technologies. And actually a guy from Hungary who graduated at the other university is the chief architect of that system in Germany. And they envisaged a significant amount of data collection, and thereby they will be, and they are currently already in position to do some advanced data engineering and data science tasks. Our CDNO project is that we actually want to monitor and analyze the monitoring data. That's the main task, but you will see that there is one additional topic. We started a little bit more than 2.5 years ago, actually, and currently we have, and I will present 3 topics. The first is more hands-on with Raspberry Pis, and the other 2 are mostly data science and data analytics tasks. So the first is the so-called demo rig, demonstrator rig, which we are currently in the process of actually finishing, because up until this moment we were buying the Raspberry Pis and the additional heads, the additional boards which we will be using in this setup, which is logically represented on your right hand side. So the idea is to put together a Raspberry Pi-based cyber physical simulator in which we can actually deploy the CDN or theoretically any other easily deployable cloud-based solution and experiment in that kind of setup. Like the first use case we will be and currently are in the stage of exploring is that we will deploy the CDN and then experiment with different kinds of theoretical configurations of the content delivery network, in which we measure the energy consumption. So because the actual system consists of 500 servers, and these are not some kind of regular servers, but high performance computing kind of hardware, and those servers consume a lot of energy. And one of the ideas and one of the actual business propositions of this joint project is to somehow lower the energy consumption. So that's why we will put together a small simulator, and in that simulator we will experiment with different kinds of configurations and algorithms and measure how those experiments affect the energy consumption. The second task is more like data science. In here we are collecting measurement data from the hundreds of servers, CPU, memory, network bandwidth, temperatures, and the idea is to do some preventive maintenance, so prediction tasks which will allow us to predict if one or more servers will fail and to avoid any kind of incidents because of that, replace the servers or their components on time. So that's the major idea. Originally, the idea was to stream the data to our servers here in Budapest, but the actual volume is so big that we dumped that idea, and we are currently exploring the data in situ on the servers in Germany. So whoever is affiliated with the department can put her hands on a lot of data. The challenge is, well, the system, this open source based system is rather new, and the data set is not labeled, so that's why currently we are working on labeling and identifying the anomalies in this large pile of data. And the third task, which I will briefly touch, is the TCP stack optimization task. Here the idea is to collect measurement data from the customer devices, so the set-top box which you get with cable television from Deutsche Telekom. So we are collecting data from the customer end, collecting data from the servers, correlating the data and modifying the TCP settings on the servers, and thereby improving the quality of experience of the customers. So that's, and in here we have one submitted conference paper. So these topics are rather new. We only started less than 1 year ago with this. So this is pretty new, and there are interesting potential for student projects as well. Yeah, in the past we had two additional project topics for which we have data, but we are currently not working on this because of resource constraints. One was client error clustering, again collecting data from the customers and clustering the client error data so that we find out what are the most frequent errors. We had one best paper conference award for that, and we also have the CDN cache optimization, in which we were actually experimenting with different kinds of the idea was to simulate the CDN purely software based and experiment with different kinds of caching algorithms. And so next steps, put together the demonstration rig, do additional anomaly detection and data analysis in that domain, and conclude the TCP stack optimization. In the latter two tasks we have data. In the first we currently have hardware programming kind of tasks. So that would be in a nutshell. Yeah, and one additional topic we are trying to communicate and sell to the partners, to the industrial partners, is cybersecurity, because our team is mainly interested in anomaly detection in the context of cybersecurity and in cybersecurity education in my case. Okay, so I guess that's all from me, I hope.
Thank you very much. We have multiple questions. So the first question is that you mentioned that it's open source. Can anyone use it, try it out? Where is it available?
The open source here is complex. So the Germans are putting together many different open source platforms and thereby creating a complex system. So the data, so the pieces of the video files are sent by Varnish. The monitoring is done in InfluxDB and Elasticsearch. So free and open source software is orchestrated, and thereby they create a big complex system. So it's not something you can actually download. This is a complex system consisting of many components. most of them open source.
Thank you. Another question is that is it similar to the global CDN commonly used by web applications for caching, such as Google Cloud Platform CDN service and so on?
Yes, absolutely. I skipped that because of the time constraint, and that's why there was no diagram in the slides. Yes, so actually this CDN system is rather similar to what Netflix is using. Netflix have an in-house system. Google and other big internet service providers or internet-based companies tend to have something similar. So in the CDN, you replicate the data closer to the customers and try to predict what will be consumed and replicate the frequently consumed data close to the customers in data centers and on servers. That's what Netflix is doing, and that's what Google is doing, as just mentioned. So this is similar to that, but orchestrated from open source companies so that they don't have to pay a monthly fee to some American company.
Thanks. And the final question is that are there any plans of researching and benchmarking alternative network protocols like QUIC, if you are familiar with that?
Are there?
Any plans for researching alternative network and benchmarking alternative network protocols like QUIC?
Currently not, because the system is in an advanced deployment stage. Something similar might be built here in Hungary as well. And this is built as it is built. So TCP and HTTP will be the actual protocols underlying the system, so that it can pass through any firewall. So the idea is to use already selected protocols.
Thank you very much for your presentation and for answering the questions. And then for our next presenter, I would like to ask Barbara Hegyi to be on stage.
Hi, good morning, everyone. I see here many familiar faces, but for those who don't know me, I am Barbara Hegyi, responsible for the innovation and entrepreneurship education at the Faculty of Informatics. And as Imre mentioned that he is a little bit engineering aspect, I here represent the management, innovation and entrepreneurship aspect. And what I will introduce you are two different opportunities to participate in our Erasmus Plus project. Here are a few students who already did, and I hope that they can share their positive experiences too. So basically, with my colleagues of 5 universities, we are always experimenting not only in this Erasmus project. We have a close cooperation in many years in different aspects, how we can embed into your education different management, entrepreneurial and innovation aspects which can help you through your career phases, which can help you to build your own project, which can help you to, when you have an idea, to bring you through the different phases how you can implement that idea, even if it is an own enterprise or you are in a bigger, larger company. So we try to give you these skills. But this project is a little bit different. In this project, we are offering different opportunities to join, and we are experimenting how we can make the education system a little bit more interconnected and flexible. So in this Erasmus project, usually referred portfolio, we are offering micro courses which are embracing different aspects of the 21st century entrepreneurship and management when it comes to tech innovation. So we try to give you different aspects how you can build not only a great idea from technical aspects, from market aspects, but also make it in a responsible way, make it in a sustainable way, which are usually very important criteria also in the market nowadays. So how you can join the micro-courses. Micro-courses are offered by the 5 universities who are cooperating with each other. And these micro-courses are available on the website. You can see it, interconnectededucation.edu. So you can check there the courses, and you can pick within the framework of the inno-social aspects of entrepreneurship course, many micro-courses offered by different universities and different topics. Each micro-course is 1 or 2 ECTS words. So you can complement the 6 ECTS career course, which we have here at the faculty, with different combinations. For example, picking different courses from different universities and coming to the summer school. I will tell more about the summer school a little bit later. And, or you can do 3 different courses, which means that you follow the micro courses of different universities. You can have the opportunity to meet virtually students from different universities and, of course, also professors. These courses, these so-called innovation entrepreneurship courses are always aiming to complement your computer science studies, to help you to see your ideas, your project from different view or through a different lens. So these are the micro courses. Those who are interested can apply in the spring semester, and there will be the choice of the different courses. Basically, this Inno-Social Aspects course is an elective course for master students at our faculty, but we have a multidisciplinary aspect which can make it more interesting, so students from other faculties used to join too. And one more thing which I want to add is that these micro courses can be also available for students from the bachelor track. But of course, we have the limits. So if you want to apply, please refer how you performed, how well you performed in the basic entrepreneurship courses. And one more thing, we have the first edition of the Portfolio Erasmus Summer School this summer, and I think it was great. And also many students from our faculty and ELTE joined. This year, next year, so this academic year, we will again have the summer school. We already have the dates for this, and there will be an application period from end of March until middle of April, most probably, but you will have the information through all the different channels. Who we expect to apply and attend? Those students who are very much open to experiment with the social market side and sustainability side of the different tech innovations, like to extend their knowledge into different disciplines and cooperate with students from other universities, and also learn from professors who will be on site here during this 1 week. So this is an ECTS course, 2 ECTS course at our faculty, and here will be students from 5 other universities, and 1 week long, the last week of the exam period. So those who can be quick with completing all the other exams are very much welcome. And the selection is made, it is very important. Centrally, there is a jury because we want to keep it in a way that we have a pool of applications from the different universities, and there will be an equal distribution of the participants. So please keep in mind, if you are interested, the application period will be from March to April. And one more thing, this is more towards the colleagues and those who are open to learn about from our experiences what we have already in this project, how interconnected education can be implemented, what are the methodological experiences. We will have online webinar, so those who are interested are very much welcome also here. So thank you very much for your attention again, and I am ready for the questions, if any.
Thank you for your presentation. We do not have any questions yet, but maybe wait a little bit if somebody is still writing one.
So, hello everyone, I'm Csaba Bálint, and yeah, I have my colleagues listed here as well, and during my presentation, please feel free to ask any questions. Yeah, and yeah, I have, so this is a computer graphics and computational geometry laboratory that I'm inviting you guys to for these topics. There will be 3 kinds of topics: computational geometry, computer graphics, and geometric modeling as well. So yeah, so short introduction so that you guys can understand what the topics are about. So for most of the topics, we use implicit functions. So these are functions from the 3D space to the real numbers. And where the values are 0, that's where we have the surface. So that's the set of the surface. Then we have distance functions, which are just functions that return the distance to this surface set. And then from these, we can build geometries with constructive solid geometry. So we combine primitives, which gives us a tree-like structure that we can use. And then there is a discrete version of this sign distance function as well. So the sign distance field, there's a lot of interpolation problems related to that. And then the sphere tracing algorithm, which which is used for visualizations. Visualizations such as this one. So the scene is constructed from union, intersection, and so forth operations. And the set of spheres here is how the algorithm works. It takes distance-side steps along array, and this is, yeah. And so the first set of topics is related to this. So we have a general surface, general implicit function, implicit surface visualization problem, which is a root finding methods, or there are many root finding methods. But in these ones, we have to find the first root, which is a typical hard problem. And then we have sphere tracing algorithms, which is actually a solution to these, but these require these sign distance functions. We should compare these and see which one is best. And we have other algorithms that relate to these. We have a sphere tracing algorithm that's faster. But we also have a novel technique, which is kind of shown there. But yeah, so these tasks require a lot of geometry and math and some algorithmic knowledge to implement. So and we do that on the GPU usually. So these methods require shading languages and so forth. So and then we have other methods related to vector graphics or other topics that we can use, and then yeah, and I think yeah, and then we have the computational geometry topics. So these are and the first one is basically, if you know GeoGebra, it's like that, but we implemented this in MATLAB, and we find it a lot better than GeoGebra because we can write scripts in it, and we can make figures like these ones where you can drag the points around, so it's fully interactive. But it has its own challenges. So we should. So there are a lot of algorithms in the background that make this run efficiently, and yeah, and during our lab we want to implement this in web GPU, or we need a 3D implementation as well, because we don't have that yet. And then we have, yeah, and then we have the Voronoi topics, which is, so there's like the, if you have a set of points, then the subset of the whole space which is closest to a given point is a Voronoi region, and we can generalize this to polygons, which give interesting regions that have curved regions, and we can describe these fairly well, but the algorithm to make this fast is rather slow. So we are trying to write faster algorithms for these, and they work well, but we don't have all the implementation yet. And yeah, so there are a lot of topics that you can join in on these ones. The extension of this into 3D is like extremely hard, and if you're looking for the challenge. So these ones, it's mostly mathematics that you need for these, and geometric algorithms. Yeah. And then finally, the geometric modeling topics, well, the first one is these local operators. It requires like a hybrid approach of discrete implicit representation, so a grid of distance values, for example, that we can do local operations on, and the global operations are done by a CSG tree. So there's a finite grid that can modify local distortions or local modeling problems, and the global modeling problem is separated. So for that, that would be an interesting topic for someone. And we have various problems regarding conversion between different representation. So for this, there's the boundary representation, which is essentially just descriptions of curves and surfaces that make up a solid object. And we have approximation, applied approximation topics regarding how to essentially approximate curves and surfaces with less data, and which is useful for speeding up rendering or level of detail problems. Yeah, and then yeah, so I talked about essentially 3 kinds of topics. You can come find me if you're interested. We are starting a laboratory next semester. You can join on Neptune. It's mostly, these topics are mostly aimed at master students. Some are good for bachelor students as well, but mostly, yeah. We have, yeah, we were working with a company, or it's as well, and yeah, thank you for your attention.
Thank you for the presentation. We have a question. You have partially answered it, but please elaborate a bit on that. What is the earliest year, and what is the required competence for the students to join this laboratory?
So, yeah, you can join from next semester, and the requirements, well, if you have completed computer graphics course, or there's the advanced computer graphics course as well. If you've done these, that's great. It's not necessarily required, but there are other courses as well. So introduction to computer graphics and geometric modeling courses, they are I think they are only available in Hungarian. So so those courses can lay a lot of foundation for these projects. But even if you don't have these, a strong mathematical background or algorithms in general, if you've played with such geometric algorithms, is great, essentially. Yeah.
Okay, another question is that if a student has his own idea for a topic, can he propose it to you?
Sure. Yeah.
Okay.
Yeah, I cannot. I can't promise that I will like it, but yeah, I'm more than interested. Yes.
Okay, thank you for your presentation then. And let's move on to the next presentation. And I would like to ask Zoltán Porkaláb on the stage about Code Compass.
Okay, so I think that there will be a number of presentations about static analysis, so it's perhaps worth to introduce what is static analysis, why it's important. So static analysis is basically a method where you analyze software without running that. That has a lot of advantages. First of all, it's much cheaper. You don't need the full runtime environments. Let's imagine a huge database system or a network system in the telecom industry or whatever. So it's easier to set up this environment, easier to run, it's cheaper, and it's much faster. Gives it you feedback about the quality of the code. You can imagine a product when the programmer introduces a new feature, and then we don't need to write the testers to write the test, to run the test, and get the feedback about the product what I just introduced, the software. Perhaps even the editor or a plugin to the editor, or when I commit the new feature, I've got an immediate feedback from the product. And that's a very important rule in software industry, that the sooner you get the feedback about an error, it's easier and cheaper to fix it. So that's why static analysis is very important, and there are a lot of areas where we use it. It's used for finding potential errors, as I mentioned, also for optimization possibilities. Well, basically all the compilers are kind of static analyzers, and they do this. Automatic code refactoring, perhaps there will be a presentation about that. Software measurements, complexity measurements, which can detect critical part of the softwares, also working with static analysis. And the areas we will speak here, that static analysis can also support understanding software, so software comprehension, as we say it. And of course, many other tasks. So why software comprehension is important? Well, it's not nice to say, but today, most of the programmers spend their time not writing new software. There are different kinds of measurements in the industry, but there is a general agreement that the programmers today spend much more time to understand software than writing new code. That software can be somebody's other software, a library you want to apply, a software which was written 20 years ago and you have to put a new feature, or was written last year by yourself, but you have to fix a bug. So a lot of effort is spent for software maintenance, and most part of that is to understand all the details of the software. Why it's important? Because every time you try to fix a bug, anytime you put a new feature in the software, you modify the code, there might be side effects, you can introduce new bugs that can be very dangerous and very expensive. So you have to have a full understanding of the code, what you touch. That's a problem, because software is complex. And when you have a complex problem, like a few million lines of code written somebody else in a completely different style, and you've lost the intentions because, well, maybe the team is already left the company or was just transferred from another site, we use tools to support us. And we know that using tools is an important feature of the humanity. But not only humans using tools, it is proven that, for example, apes are using tools. Unfortunately, software programmers not always use tools, especially not for code comprehension. It's very frequent that you have some source code, you try to understand the part, and then the next day you forget it again. So tool support for code compression is important. And that was our target, to write a utility, a complex software which can help programmers to understand complex software systems. And I'm not speaking about your homework or your daily tasks. I'm speaking about many million lines of code with hundreds or thousands of source files, perhaps written in multiple languages. And of course, documentation is not valid or just outdated or not exist at all. So basically the source to understand this code is the source code itself, perhaps some other information like the version control, whatever. So we introduced a new tool, Code Compass, and actually you can try this code pretty easy way because there is a codecompass.net site. When we have a number of products parsed, you can just visit this site with a browser and then you can check what Code Compass can do. The tool itself is completely open source. It was developed with the support of Ericsson, so that's why it's under github.com Ericsson. It is used widely in a number of companies, namely mostly in Ericsson, Graphisoft, Cloudera, and a few other companies. But this tool does no spying about the customers because source code is very confidential many times. But you know, if you get an error report from an IBM official address, you can guess that IBM is also using this tool. This tool is scalable up to millions of lines. And you can see, for example, LLVM, the compiler infrastructure is fully parsed, and you can test it. It supports mainly C and C++, but there is an ongoing, almost finished project to support Java, C#, and Python programming languages. There are lots of graphical innovations in these tools, so you can easily browse the code, go for different kind of programming elements, a usage of a template, usage of a type, where a variable is written, how is a function call chain is coming from one point to the other. So there is a lots of tasks here. And as a student, you can join this program in a different level. You might implement a new kind of visualization. You might just try to find a bug and fix it. You might just make some fix of the C++ code browsing area. But if you are MSc student, you might be interested in introducing your favorite programming language to the Code Compass. Code Compass is has a pluginable infrastructure, so it's pretty easy to put a new programming language or a new visualization, a new measurement into the code. So not only Code Compass, but the tasks regarding Code Compass are scalable. You are very welcome to join this project. This is just a screenshot from Code Compass, a new kind of browsing techniques. Those entities might be functions, class definitions. They might be in different areas of the code, different source files. In a classical editor EDI, it's not easy to use them. So a new kind of visualization is a perfect task, for example. Okay, what students do, new visualizations, new programming languages. There are lots of programming languages we are waiting for you. Rust, Golang, TypeScript, JavaScript, even perhaps the shell script browser might be a task for you. Unfortunately, there are some prerequisites. Since this is static analysis, there's an advantage if you have some knowledge of compiler technologies, and of course you have to be a pretty stable programmer, at least on the favorite programming languages you want to implement here. So you are welcome to join this project, and you can visit the website, codecompass.net. There you will see thesis proposals from our side, both on BSc and MSc thesis. And you can find me or our colleagues listed in the website of this event. If you have questions later or now.
There is a question now. You have mentioned a lot of programming languages, but somebody was especially interested in PHP. Were there any plans for integrating PHP?
Well, it depends whether there is a student who wants to implement that. Of course, it's very welcome.
Okay, thank you for your presentation, and of course, you can also ask questions after all the presentations. And then I'd like to ask our next presenter, also related to static analysis, Tibor Brunner.
Hi, welcome everyone. My name is Tibor Brunner, and I'd like to present you the CodeChecker project, which is developed in cooperation with Ericsson and ELTE. So again, this is a static analysis tool, which means that we are analyzing the source code without executing that, as the previous presenter mentioned. And this technique can be used for many purposes, like finding software bugs, and this is what I'm going to talk about in this presentation. But we heard the previous presentation about the code comprehension. We can also use this for checking code conventions and so on. So this technique can be used in several fields. So one word about the differences between dynamic and static analysis. You might have heard about the testing technique, which is a dynamic analysis technique, which means that you actually have to compile and run the code in order to check its behavior. In static analysis, we are simply just compiling the code. We are reading its source code and trying to make assumptions about their behaviors and tell them if they are correct or not. So testing is checking the source code from the point of view of the features. Are my features working the same way as they did in the previous version of my code? But in static analysis, we are checking the source code from the bugs point of view. So we don't know anything about the project itself. We just want to check if they are containing division by zero, no pointer dereferencing, stack overflow issues, array over indexing, and so on and so on. Let me show you how this works on a simple example. I promise you this is the only source code that I'm going to have in my presentation. Here is some computation, which is defined by a function. It requires one parameter. I have an array of 10 integers, and if my parameter is greater or equal than 0, then I return 1 divided by the parameter. Otherwise, I'm just returning that element of the array. If you are an experienced programmer, you can pinpoint at least 3 or 4 mistakes in this code, because there is a possible division by 0, because if the parameter can be equal to 0, then there is a possibility for dividing by 0. On the else branch, the parameter is definitely negative, and this is an array under indexing issue. And by the way, why do you return 42 if both the other branches return something? So yeah, actually, if you are executing CodeChecker itself, it has managed to find 13 issues with this simple kind of code. The serious ones are the last 3. So CodeChecker itself managed to find the division by 0, the array under indexing, unused variable issues, and there are some style issues as well, like why didn't I put curly braces around the return statements? It might be some coding convention. But the idea is this one. The second thing is that not only we would like to find these bugs, we'd like to visualize them. So it would be nice if you had a graphical visualization showing you with the red arrow that assuming that variable is like this or like that, then the control flow can go that way, and there in your code in line 6 you are going to have a division by 0. So feel free to execute this CodeChecker tool on your garage projects, on your assignments, exam tasks. And maybe you can find some mistakes that you haven't thought of earlier. So the idea for using CodeChecker, this is a diagram which presents that the user has to contact the CodeChecker command line interface, which is able to execute multiple analyzer tools. Currently, we are contributing to Clang Tidy and Clang Assay static analyzer, These two tools were developed by Apple and Google, and Ericsson is one of the main contributors for these projects. And we are also opening towards other languages, and Spotbox is a Java static analyzer that we are contributing to. The results of these analyzers are stored in a database, and then you can check them on a different kind of visualizations. You can integrate them to your VS Code, because we also have a VS Code plugin in order to find bugs at the earliest possible stage of your development. So any of these parts can be extended in the frame of this project. So the use cases of CodeChecker is finding actual bugs in the source code, visualizing them in the most comprehensible way as it is possible, and we are also supporting the management of the reports. So for example, if the boss of the project is interested how many reports, how many bugs have been fixed compared to the previous version of the project, we can visualize that with different kinds of statistics. We can integrate this tool into the CI systems, so we can actually block the deployment and the release of a project in case of the appearance of new bugs. And we are also extending the VS Code plugin. This is a screenshot about the project. This is just the 13 reports that we saw previously. We can visualize them through diagrams. What is the life cycle of the project, and I can filter the different kinds of reports based on what kind of issue had been found, like division by zero or something else. What modules of my program are containing the most bugs in the project, and so on and so on. So we have this web-based visualization that we are presenting. If you are joining to this project, then you might be familiar with most of the technologies that we are using in this project. The CodeChecker itself is written in Python. It is open source. It is available. On the next slides, I'm going to give you some links where you can reach these projects. So CodeChecker infrastructure, which drives the analysis, is available in Python. We are using C and C++ in Java analysis for analyzing the source code. But if you are familiar with other static analyzer tools for other languages, they are very welcome, because we are planning a pluginable interface for CodeChecker, so it is easily extendable with the analysis of further languages. And then we have the web interface, which is written in TypeScript using the Vue framework. You might be familiar with that one. We are using the Postgres SQL database. It is an interesting one. If you are interested in the database systems, sometimes we have issues with the big amount of reports that we need to handle and maintain in the database. So that is an interesting section of the project. And also, we are using a remote API for storing the issues, sending the reports to the web interface, asking them, querying them, and so on and so on. And the Thrift API is doing that. In this slide, you might see some links. And so, as I said, the CodeChecker itself is available on GitHub. It is a completely open source project. The second link is a demo page. So even now, if you click on the second link, you can check a demo page of the CodeChecker with some analyzed projects. We are contributing to these three analyzers, the static analyzer, the Clang Tidy, and the Spotbox for Java. So if you intend to find different kinds of errors in your source code, then you can extend these analyzers. And I have some contact email addresses if you would like to join to these projects. Mine one, Mate and Zoltán, they are working with students at the ELTE side. And this was my last slide. Thank you for your attention, and if you have questions, feel free to ask them.
Thank you for the presentation. We had the students in the audience have multiple questions. The first one is that, so the first question is that, does CodeChecker only extract potential errors or also make suggestions how to fix them?
Yes, Clang Tidy has the ability to provide fixes, and CodeChecker has a functionality which automatically applies these fixes. I didn't say in my presentation that these tools have different strengths. I mean, we have this control flow and path-based visualizations and analysis that I mentioned, that if your control flow is coming here and going there, and there is you are going to have a division by 0. This is done by Clang static analyzer. It is not easy to provide an automatic fix-it for that. But Clang tidy is a simpler code. It is just checking the structure of the abstract syntax tree if it tells something for you. So it is checking the structure of the code. So for example, do you have a division operator anywhere in your code of which the right-hand side has a 0 value? And these kinds of easy structural mistakes can be automatically fixed. So yes, we have some functionalities for applying automatic fixes for bugs.
Thanks. There is also a question can you clarify a bit that what is the major difference between Code Compass and Code Checker, because they have similar functionalities and both of them are supported by Ericsson.
Yes, these two projects were developed in cooperation with ELTE from the beginning. Code Compass is the more major one. Both of these projects are using static analysis. So both of these projects are not compiling the code and, not executing the code in order to analyze them. But their main purpose is different. Code Compass's purpose is to give visualizations in order to make people understand large code bases easier. So for example, Code Compass contains different kind of generated class diagrams, function call diagrams, blah, blah, so many different kinds of visualizations that are making code comprehension easier. On the other hand, Code Checker is checking the source code and tries to report bugs and errors in it. Okay, so the main purpose, the goal of the projects are different, but the technique that they are using is the same, which is static analysis.
Thanks. There's also a question that why is it beneficial to use Code Checker? Why isn't simply enough to use Clang tidy, for example, if the results will be the same?
So if I understand correctly, why not just natively use Clang tidy, right?
Yeah, so why not just use Clang tidy?
Yeah, the advantage of using Code Checker is that it is pluginable and you don't have to worry about how to parameterize the analyzer tools. So if you are checking what command you are providing to the command line interface in order to execute Clang tidy, this is going to be a this long command. On the other hand, if you are just saying Code Checker analyze this project, you hit enter, and it automatically drives all of these analyzers. No matter what language your project is in, no matter what tools are integrated in Code Checker, they are automatically parameterized. Code Checker helps you to monitor the reports, manage the reports, provide them on web interface. So this is actually just an infrastructure of the analyzers. Obviously, you can execute Clang tidy natively, but our users, so for example, if we are providing this to the users in Ericsson, for example, the project's developers don't want to know how Clang tidy works. They just want to analyze their project. They just want to Code Checker, analyze, enter, whatever it does. And they want to see the results.
Okay, thanks. There is also a question about that currently what programming languages are supported by Code Checker, and are there any functional programming languages or are there any plans to support them?
Yes, if you go to the web page of Code Checker on the GitHub page, I mentioned the Spotbox tool and the Clang tool that we are the contributors of. So we are currently contributing to Java, C, and C++ languages, and Objective-C because Clang is supporting that as well. But we have a set of other analyzers like PyLint for the Python language, PyCode style, GoLint, and name your favorite languages. Most probably you are going to have some static analyzers for them. We are planning to restructure even more the architecture of Code Checker being able to execute these analyzers. But even today, we have a so-called report converter, which converts the output of different languages analyzers to the Code Checker format. So in a halfway, we are already supporting at least 10 other programming languages. But they are not directly integrated into Code Checker yet.
Thanks. Another question is, it's a bit funny one, that why is Code Checker better than using, for example, generative AI checking the code? So how would you compare using Code Checker for checking the code for potential programming errors versus using a generative AI tool for checking possible programming errors?
Last week we had a the hackathon at Ericsson, and two of my colleagues were working right on this topic that somebody asked right now, how to integrate CodeChecker with artificial intelligence. And they were trying to use artificial intelligence how ChatGPT could understand the bugs of your source code, and how could ChatGPT categorize them. How confident answers does ChatGPT give on these reports? This is a research project, actually. So if you are interested in this topic, you could join to this project. We are starting to use the benefits of the AI to find bugs. So far, we have some results. It is not convincing yet from what I saw from this hackathon, but it will definitely improve in the future.
Thank you. And the final question is that what is the expected experience and knowledge from the students to join the CodeChecker project?
Well, actually, CodeChecker has different layers, and maybe the toughest one is joining to the analyzer team. So if you would like to provide new kinds of checker, if you would like to improve the analyzer engine, it is a hard one. Okay, so you are supposed to be a little bit more experienced by doing that job. But if you would like to improve the infrastructure itself, the CodeChecker itself, then this is a Python project, and I believe enthusiastic students can already join to our projects. We are expecting web developers because in our team we are touching the web GUI in case it's extremely needed, but it would be nice if somebody could join to the web GUI part of the project. So yeah, even beginner students can join, I think.
Okay, we have another question, but really this will be the last one, so we can move forward. Is there any plan in CodeChecker to find bugs across projects? So for example, the backend is written in some programming language, the front end is written in different programming language, and the contracts are defined in schemas, and in this case, can, for example, CodeChecker find a bug? I think if I properly understand the question, that they are not connected properly to each other, and so on.
So your question is about the analysis of multi-language projects, or?
Yeah, if I understand correctly, the analysis of multi-language projects and even the connection between these multi-language projects. So for example, a back-end project and the front-end project.
Maybe the first answer is that CodeChecker is analyzing multiple languages. If I understand the question correctly, you would like to analyze the connections between those modules. And this will depend on the strength of the analyzer engine. The current analyzer engines, I haven't seen one which does this kind of analysis. But if you are developing that, feel free to integrate that to the CodeChecker. What we have, and this is another part of the question, how do you analyze big projects if they are having multiple modules? Because if I go back to my previous example, I had only one function. Is CodeChecker and the analyzer's engines able to go through function calls? So what happens if this computation is called by another function, which is called by another module? Well, actually, Clang Static Analyzer is able to do the CTU analysis, which is the cross-translation unit analysis, which goes through these borders inside of the language through function calls, even if that function is defined in another module of the project. So these kind of boundaries we have language boundaries currently. But yes, Clang Static Analyzer is able to go through modules, through function calls, even if they are defined on very different places of your project.
Thank you. That would be all. Thank you for all the answers for these questions. And the next presenter will be myself, because I also have a project presentation, maybe even two. So I will continue. The first project I would like to present about is the TMS, or Task Management System. It's a web-based assignment management system, and I think most of you are already maybe familiar with this system because we are using this tool and more courses, especially in the bachelor training program. So the basic functionalities of this task management system is that lecturers, of course, can create tasks for the students, and the students can submit their solutions for these tasks. Of course, this is a very basic functionality, and in case you have only used this tool as a student, this is basically the complete functionality that you can access. But behind the scenes, and especially for the instructors and the teachers, there are a lot of further functionalities which we are working on and developing. So, for example, we have automated evaluation for the student solutions, so the instructors and the teachers can set up the rules and expected compilation commands and the expected tests for that task which should be evaluated. We also have automated static analysis. This is quite a recent feature in this task management system. We have implemented it in the summer, and right now we are introducing it in a few courses already. And in this case, I would like to mention that it's tightly connected, for example, with CodeChecker. So we are using CodeChecker in this case for performing the static analysis, and the reports made by the CodeChecker are available on the web interface of TMS itself. And in this case, I would also like to add, for example, that it was also a good opportunity for some participating students to also extend the CodeChecker. So, for example, Tibor did not mention that the C# support, but for example, we added a C# support, and it was quite easy in the end because there are existing static analyzers for C#. Of course, Microsoft itself has its Roslyn static analyzer, and the only expected task to do was to integrate the output format of this Roslyn static analyzer to be compatible with CodeChecker, and after that the CodeChecker web interface is capable of showing all the results of the Roslyn static analyzer. And in this case, for example, the event-driven programming, which is a third semester course in the bachelor training program, we are already using this tool, and we are expecting to further develop on this and integrate this on more courses in the future. Of course, all of these evaluations are performed in secure Docker containers, so of course a funny student code cannot mess up the host system and so on. Teachers also have an automated plagiarism checking tools. In this case, there are various online tools and offline tools which are available for plagiarism checking, especially source codes, and we are integrating them. Of course, there is also an option to implement a custom new plagiarism checking tool, but right now we are integrating existing ones in this case. And we also have an integration, for example, with Canvas learn management system, and in this case it's quite beneficial because Canvas has a lot of functionalities which we wouldn't like to re-implement. So you can basically post a lot of information about the course, the curriculum and so on Canvas, and we wouldn't like to re-implement all those features in our TMS program, but Canvas itself does not have any capabilities of analyzing and evaluating student submissions. So in this case, we would like to integrate these two systems together, and that's already made on a level. It could be further improved because right now this integration is mostly the TMS fetching all the data from Canvas, crunching and evaluating all the student solutions and submitting back the results, but there could be a tighter connection between the two systems. We also have integration with the Git version control system. It's especially useful on courses where there are larger submissions and there could be made multiple submissions, and in this case those submissions could be version controlled, for example. So these are the main functionalities of this system. It's available, yeah, I have the last slide on, it's tms.inf.elte.hu, so most likely you've already used this system. If you are interested in developing this web-based application, you can join this project. We are expecting students who have already completed their software technology course, it's a 4-semester course, to apply, or also for master students, it's a valid option. We have already gathered collected quite a lot of data in the past years, so we are using this system quite a few years ago. And there is also a possibility, an option, for example, for performing some kind of research and analysis. So we have multiple thousands of students who use this system, multiple thousand tasks and submissions which can be analyzed. And for example, this was a good basis when we introduced static analysis, that before we implemented this new feature, first of all, we evaluated submissions from previous semesters and verified that there are quite a few and typical user errors, programmer errors in the student submissions, which were accepted and graded, for example, 5 or 4, so they had a good grade, but still there were quite a lot of errors in them, because most likely the teachers did not have the time to go through the all the complex submissions line by line and find all the possible errors. And in this case, the static analysis can aid both the teacher and both the student to learn more and gather more of these possible errors which are present in the source code. Yes, and on the final slide there are some contact. This is also an open source project, so you can find it, in this case we have it on GitLab, not on GitHub. This is my email address, and there's also some statistics, so you can see that quite a lot of students already contributed to this project. So we had multiple bachelor theses and also master theses from this project. You may ask that since this project is mostly about implementation, what could be a possible research, for example, for a master thesis or for a TDK thesis? In this case, you can think about static analysis and evaluating student submissions to find possible and typical errors, integrating and developing better plagiarism checking tools those are potential research topics which can be good for example, a master thesis as well. So yeah, that's all for my first presentation. I will step back to be the moderator and see whether there are any questions. Is the static analysis used for code quality for TMS? Or to help instructors give feedbacks in a fastly manner. The reports made by the static analysis component in TMS is visible both to the student and both to the teacher. So it's helping both of them. For the students, it's a help because they can see that there are potential errors in their source code, and if they are before the deadline, they can usually resubmit their solution and most likely get a better grade in the end. For the instructors, it's a help because they can get, after the deadline, they can get a list of errors which are present in the source code, and of course it's help their grading the submissions in a faster way, so it's helping both the students and the teachers in this case. Yes, has TMS been audited from a cybersecurity perspective? Well, we are putting some effort and focus for TMS to be, of course, as secure as possible, but there was no special audit, cybersecurity audit for the project yet. Of course, maybe if in the later it will be used by multiple universities, which is a long-term plan for us, if it would be inevitable to have a security audit for the project. Are TMS and Canvas running on ELTE servers, or are we deploying to a cloud provider? Currently, they are running on ELTE servers. So for Canvas, I just guess so because in that case, we are not maintaining Canvas itself. We are just integrating with them. The TMS is executed on faculty servers. Right now, we are working on decomposing especially the backend of the project into microservices, and in this case it could be feasible, for example, to deploy it to cloud providers, but connecting to the previous question, it might not be a good idea to deploy our data set with confidential data and student submissions to the cloud. So that would be a potential option to do that, but I think that even in the future we will execute and maintain the TMS on faculty servers, but in a microservice concept in the long run. Will TMS replace the Mester submission system? Since I am the project owner or project manager for TMS, maybe I can say that I hope so. Maybe the other developers working on other projects, they will say otherwise. Of course, I think it would be beneficial that in the end there would be a single submission system used at the faculty. The reason that there are multiple that they were all started at a similar time years back, and all of them started to be developed on their own paths. But I think we are going towards a unification. So a couple of years ago, there were 4 submission systems used at the faculty, and right now, as far as I know, there is only the Mester and the TMS left. So we are going towards that only one system will be used in the end. Yes. Is the integrated LMS system, so Canvas, incorporate a recommender system that would suggest materials for the students to improve their grades? Well, it is based on what do you mean by this recommendation system? So right now the integration is at the level that the TMS can access the data, also the tasks and the solutions which are present in a related Canvas course, and download them from Canvas, do anything with the downloaded version, of course, so compiling it, running black box tests on it, static analysis on it, and make a comment. So TMS can act as the instructor, and in name of the instructor, the TMS can post a comment on the submission which will be visible in Canvas. To make a recommendation to improve the grade, well, if you say that, for example, there were 10 test cases and 8 of them failed, that could be a recommendation that you should pass the remaining 8 tests. So the grade will be improved at that level, for example. So it's the same level like we are already having in TMS. Yes. And thanks for the questions. I think I've answered all of them. So let's move on. I also have a different topic and a different project. It will be about geoinformation and remote sensing, and I will do this together with Tekla Tóth, my colleague. We are leading this lab together. And then maybe I will start and then give you the opportunity to show your own projects. So we also have a geoinformatics and remote sensing laboratory at the faculty. And in this laboratory we have various topics which are more tightly or loosely connected, so there are quite a couple of options. Basically, I would like to just showcase some of the results and some of the projects which were active, either active now or were active in the past, and to just for you can get an idea and the concept that what we are doing in this lab, and are you interested in or not. So one of our projects is maybe before I start introducing this project, I will also add some general information. So regarding this geoinformation and remote sensing labs, we are working with various sources of data. So we are working, for example, with satellite images. Those could be only like RGB satellite images, but also multispectral satellite images, which are beyond the visible spectrum for the human eye. We are also working, for example, with drone imagery, for example. We are also working for quite a lot of the projects are related to LiDAR sensors and 3D point clouds. These point clouds could be either created, for example, aerial, so from mounted on the LiDAR sensor on an aeroplane. These point clouds can also be collected on the surface. So, for example, putting the LiDAR sensor on a car, on a train, or some other kind of vehicle, for example. And basically, these are the most frequently used data sources in our laboratory. So we are not only working only, for example, with raster imagery, but also with 3D point clouds. And in this case, this first project is about change detection on the surface, either in the vegetation or in the buildings. Based on 3D point clouds, which were collected airborne. So basically, in this case, the LiDAR sensor was placed on an airplane. And some countries put quite an effort to create large point clouds. So, for example, both the Netherlands and Estonia have already scanned the entire country multiple times. In this case, for the Netherlands, it was like 4 times already, and for Estonia, I think it was 3 times already. And in these cases, it's possible that if we have a point cloud, for example, from 2010, and we have a point cloud from 2015, there is a 5-year difference, and in this case we can analyze these point clouds, compare them to each other, and get the difference either in the built-up area, so for example for buildings, or the vegetation growth, or the vegetation reduce, and so on. Right now the vehicles is underlined because the current topic in this project is detecting vehicles, especially in cities, and even maybe change detection for them. A challenge in this project is that we are working quite with big data. So, for example, for the Netherlands, one scanning of the entire countries is around 20 terabytes of data. So, in this case, we are really working with big data, and we have to process all this information. Another project which is also related to point clouds is the railroad infrastructure recognition and error analysis. In this case, the LiDAR sensor was placed on a train, and it's going through a railway, and as a result, we receive quite a dense point cloud. In that point cloud, we have to find all the related railway infrastructure, so the railway bed, the rails itself, the poles, the overhead cables, and so on. And the goal of this project is that each railway operator has to frequently check the state of the railway infrastructure. So, for example, like possible errors is the height of the cables, maybe they are too low or too high, so maybe something, even just some vegetation is too close to the passing trains, for example. The railway bedding can be deformed, and even the railway sleepers, which are connecting the rails, can get synced into the railway bed, and these are all potential errors which have to be fixed. And these are currently requiring manual inspection, basically in all countries, not just in Hungary. And the goal is, and quite active research topic currently, is to automatize this process. And for example, LiDAR sensors can be used that based on these 3D point clouds, maybe we can find some of these errors automatically, and we do not need that much manual personnel to do these inspections. Yes, and the final project which I would like to introduce will be a bit different one, because in this case it will not be based on LiDAR sensors, but instead it is working with the multispectral satellite imagery. And we have a cooperation with a non-profit organization in Hungary named PET Kupa, who are working on making the larger riverways like the Danube and Tisza and their side rivers more clean, because there could be quite an amount of garbage, especially they are focusing on plastic garbage, which can either create like floating islands on these rivers, which in some cases can stop on the river. So, for example, here we can see the Kisköre hydro power station, and in this case there is a dam, of course, and behind the dam there could be like a plastic garbage island collected up, and also this plastic garbage can get washed up ashore next to the riverbed, and so on. And this non-profit organization, this PET Kupa, are placing quite a lot of effort on collecting these plastic garbage in Hungary. And they have also like partner institutions in other countries in Europe. And our cooperation is that based on multispectral, high-resolution satellite imagery, maybe we can find these potential places where there is a lot of garbage. Of course, in this case, our goal is not to find a single bottle, but there are larger accumulation of plastic garbage. We can locate those places, and in this case, we can especially tell these activists to go there because there is the garbage, and they do not need to find it themselves. Okay, and that will be on my side, and then I would like to give the stage to you, and I will also give you a microphone.
Thank you very much. So welcome everyone. I have two topics to introduce here. These are computer vision related topics, which means that we do not work with airborne based data or LiDAR, for example, but we have some sensors here at the university mounted to a go-kart, and also for a car. You can find it actually here in the basement. And we have several sensors like digital cameras, LiDARs, IMUs, etc., GPS. And the first task is to find the main reference frame for all of the sensors. So we would like to estimate the rigid pose between them. And we have several algorithms, and some students started to implement these existing methods. Typically, we use a target-based method, which means that we have a specific object with a known geometry, which can be found both in the LiDAR point cloud and in the images. And after detecting them in 3D, we can align these set of point pairs, and based on them, we can find this transformation matrix. Here you can see two examples for the spherical calibration. In the first image, you see that we reprojected the regarding sphere points to the image, and else, which is more interesting, we can give some color information for the LiDAR point cloud and use the sensors with different modularities in this nice way. The other application, if we have a non-calibration data, then we can generate meshes from the point cloud, and else we can just develop this point cloud colorization as well. We have 2 students working on that project so far. And if we can triangulate the point cloud and then generate some texture coordinates based on the images, then the results will be more interesting and more detailed, as you can see in the first image in the bottom row. And an upcoming test is object generation. So using this combined information, we can detect the walls and the other smaller objects like the windows, the cars, the pedestrians in the scene more efficiently. So this task requires maybe the computer graphics course, because the transformational and mathematical background is a bit important at the beginning, but else feel free to join our projects. And
thank you. Well, these are just the contact information and also some summary about previous student contribution, that these projects are eligible for creating especially master theses, in some cases even bachelor theses. And we have some questions. Yes, can first-year students join these projects? Well, it depends on whether you are a first-year student on a master or on a bachelor program. So these projects are especially for master students. In some cases, also bachelor students can join them, as you can see that there were some theses created during them. But there are various courses in the master training program, like geoinformatics, geoinformatic databases, computer vision, which you can apply for, and those courses can help your understanding significantly to join these projects. I think that was a related question, another question, that what are the related courses. So in general, of course, if you have already knowledge about 3D point clouds, for example, and how to process them, of course, you can still join the project, but especially we are focusing on master students. Maybe I can say the same for this.
Yeah, it's really the similar. So from second year, maybe it's more practical during the BSc, or we are waiting for MSc students.
Yes. Okay, are these findings used in real-life problems or rather for research and educational purposes? Well, in my projects, for example, this waste detection is used for solving a real-life program, and also the railway infrastructure analysis is a real-life problem. In that project, we are cooperating with the Hungarian State Railways, so with MÁV. So in this case, it's also, we have quite an industrial partner, even it's a state partner. So we are trying to solve some real-life problem here.
Regarding the computer vision projects, we are really proud that in the first hand, these are our own real-world data, so we can generate data for ourselves for research projects, but also we have some connections with Bosch companies, so there are other topics which are used in the industry as well.
Yeah, there are further questions, but they are all similar, that working together with companies, yes, we have mentioned them, and about the expectations we have also mentioned. So thank you for joining the stage, and thank you for the questions. And the next presenter will be Turcsányi Szabó Márta. She was here like a few minutes ago. Or otherwise, I have been informed that Péter Rakita has arrived, so maybe then we shall continue with your presentation.
Our project is related to quantum computing. Okay, this is a really hot topic these days, and we know that there are many problems around it. Before quantum computing became a useful field in information processing. You know? And in our research, we are addressing many of these currently open issues. For example, you know, if you would like to run a quantum program on a processor, quantum processor, because they are very noisy today, you know, we are living in a noisy intermediate scale quantum computing era, we need to formulate our programs in a way that they should contain as few operations as possible. This is what we call compression of quantum programs into as few as possible quantum mechanical operations. Here in the slides you can see a quantum circuit consisting of 4 qubits, and the black lines just indicates the timeline of the qubits, and we see that many quantum logical operations are applied to the qubits. This is a quantum program. We would like to reduce the number of these operations, and in the literature you can find many algorithms to address this problem. We have developed our own, and we also compared our you know, the efficiency or the performance of our approach to competitors like the Qiskit, which is the most, I think, the most famous quantum computer programming framework at the market. But there are other tools like QFast or QSearch, which are designed to optimize quantum circuits, and we are developing the Squander project, which can be found in the middle of this table, and we run these tools to decompose, to compile several quantum programs that can be found in an open database somewhere on the internet. Okay, it's not important what they mean, just to know that they are quantum programs, and as you can see, Squander provides very good results compared to the competitors. In most of the cases, we have the smallest gate number in the circuit, which is a huge progress, I think. We could also scale up our computation to larger quantum programs. Here we introduced or incorporated special hardware to speed up our calculations. In particular, we have designed a universal quantum computer simulator on an FPGA chip and on an AI chip that was manufactured by a US chip manufacturer named Grok. They are relatively new in this field, but producing very interesting computationally very powerful chips. And we have some of those boards here at the Eötvös University on the 6th floor, integrated in one of our servers. We are also addressing another very timely question in training quantum circuit. Okay, here we are speaking about quantum machine learning. There are a very common problem in training of quantum circuit, namely that as more your circuit is expressive, it is harder to train it. If you know, in traditional machine learning applications, you are calculating the gradient and train your model in the direction that is prognosed by the gradient. In training of quantum circuits, the gradient vanishes exponentially in a big part of your parameter space. And this is a big issue because this way your quantum circuit becomes untrainable. Okay, there are tons of papers addressing this problem, how to avoid these so-called barren plateaus where the gradient is, or the landscape of the cost function is flat. We have also developed an approach based on some evolutionary optimization algorithm, and this is the performance measurement of our algorithm. The specific problem is not important. Important is that the blue line, which is the result of our evolutionary algorithm, decreases much better as, for example, traditional gradient descent method of Adam. Okay, so basically these are the problems we are addressing in our research projects. The software stack we are developing is integrated into a single project that can be found in GitHub. So if you are interested, you can look up this project called Squander. And if you find interesting our work, you can contact us or me using this email address, and you can also check that how many grants are supporting our work. So this is a project where quantum mechanics and high performance computing meet each other. So if you feel yourself to be sufficiently motivated, then you are welcome to join our group. Thank you very much.
Thank you for the presentation. I will check whether there are any further questions. As a final step of this Projekt Fórum, I was asked to draw a few names since the organizers have prepared with a couple of gifts. So there was an online registration phase for the event, and I would like to draw three names. In this case, Murad Mamadov. Oh, come, please. Thank you. Katona Fanni. Thank you. Thank you. And the last one, Kis Ádám. Congratulations. Thank you. Okay, so with this drawing, I would like to conclude this Projekt Fórum. I hope it was useful for you. You gathered useful information about these projects. Now, as I have promised, there is a little catering over here. So if you have still time and you would like, for example, to contact one of the presenters, or you would like to just do some networking, please stay. I would also like to presenters, if you have a little time left, please stay here if there are any students who would like to ask further questions. And I was also asked that to promote the next event of the organizers, the Student Support Center, which will be November 24, which will be Master Specialization Day or Master Specialization Forum, and it's especially good if you are finishing your bachelor program right now and you would like to get information that master specializations are available, then please come. It's November 24. Thank you for your attention.